Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
If you have to deal with the ever-increasing complexity of developing cloud-native apps with modern tools, then it behooves you to use industry best practices to develop these apps. In this episode, we're going to talk about 12-factor apps, which encapsulate some of the best-in-breed practices for modern application development, particularly around DevOps. So, Will, what's been your best in breed this week?
I've been dealing with the support channel this week. It's my team's turn to do that. And we onboarded a new guy last week. So I just feel like I've been running around with my hair on fire because, something will break and you got to go look at it. And then he'll have a question because, we had maybe a gap in our onboarding training or he missed something and you got to go help with that. And then I'm on a couple different committees and they had those meetings this week too. So, I don't feel like I'm terribly effective right now. I feel like I'm very multi-threaded, not so effective this week. It'll get better next week. It's just, too many things hit at the same time. So how about you?
Well, we've got what they call lab. It's kind of like a shortened week, but lab week. Basically, when they were a full Scrum team, they had lab day. So at the end of every sprint, there was one day where you could just work on side projects, catch up on training, whatever you wanted to do. But since we now have two Kanban teams, we did a lab week, which was a full 5 days a few months ago. And now they're doing a 3-day version of it right now at work. So that's kind of fun working on
Mine's
a project.
We've
got
the same kind of deal.
Working on a project for one of our Scrum Masters. And then in my spare time, I have been typing up the notes that I wrote for the group I'm leading. Basically, I spent a lot of time studying and writing this up for this small group I'm leading at church. And then I'm typing it up so I can both turn it in and print out like the discussion questions for the group members. So it's got basically a set of scriptures to read based around a topic and then some short answer questions that we're going to use to facilitate the discussion in group. So it's going to be pretty cool. We have 10 weeks. The semester is 13 weeks, but we've got other things going on 3 of the weeks. So there's 10 weeks. I've written out 6 of them and I have to type up 3 of them to turn in before the semester starts next week. So, but yeah, that doesn't really take a lot of time. They're just taking what I've already written down and typing them up. So I did something really, really fun this past weekend, guys. Went to the Lindsey Sterling concert. Y'all, that was amazing. I mean, she just keeps getting better and better every time I see her. She's already made it up to the second best concert I've ever been to. This might have pushed her into the top. I'm still processing the whole concert, so I haven't decided if she's beaten Garth yet, but she is right there. Had front row seats for the first time ever at one of her concerts. That was amazing. The stage was a little bit high, so I had to stand up a couple of times to see stuff. And it's funny, depending on the crowd. Sometimes you stand the whole time at one of her concerts. Sometimes you sit. She's a dancing hip hop violinist. You never know what you're going to get, to be honest with you. Of course, it was at an amphitheater, so the concert was delayed quite a bit because of storms. So I am actually still a bit tired. That was Saturday night and it's Tuesday. I have not caught up fully on my sleep. So yeah, I'm still I'm making it, but I was in a meeting this morning with the guys I'm working on the side project with, and the guy we're building it for, and I was telling him about it. I was like, yeah, I'm like, I've reached that point where I've gotten enough sleep to start, like, I've caught up enough to feel the tiredness. And the guy we're building this for, he's like, are you a nap person? Like, you could totally just go take a nap for a little bit. Like, I like the way you think. Like, not sure I want to do that on the clock, but I like the way you think. I will say, though, the best part of the concert, and this was absolutely amazing, was the surprise appearance of Amy Lee. And for Will, who is not familiar with musicians, Amy Lee is the lead singer of Evanescence.
Okay.
I'm sure you've heard of that band. Yeah. Yeah. So a couple years ago, Lindsay performed a song on Evanescence's album. And then Amy Lee came and sang this song for Lindsay's most recent album. And they went on tour together. The closest they came to Nashville was, or the closest the tour came to Nashville was Louisville, Kentucky. I drove up there, bought tickets, drove up there, only to find out that there was like 4 or 5 concerts that Evanescence had already made a commitment to something else, and they weren't there with Lindsay. So I didn't get to see them together. So actually getting to see Amy Lee with Lindsay was so awesome because I didn't get to when they were on tour together. Best part of the concert, though, is Amy Lee. She's like at the front of the stage. She's just like singing, just belting it out. And Lindsey Sterling is suspended above the stage, hanging upside down, playing violin.
Wow.
Yeah. I showed that. I took several pictures of that, and I showed it to one of my friends at church who plays violin. And she's like, I can't even play her stuff like sitting down with sheet music. Like, I don't even know how she can do that. I'm like, yeah, she is amazing.
That's why it's her stuff.
Yeah. The pic I took is the one that I showed my friend is actually my team's background image at work right now. So I'm like, that was so cool, man. Like, that's just awesome. That was really neat. It was cool. Saving money is hard, especially when you spend it all on concerts and concert t-shirts.
I was expecting that from you, actually. Lucas Casades is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
Yeah, and just like us here at the podcast, his focus is on helping you not only establish a real plan, but to take action so that you can live your best life.
Yeah, and investing in financial planning services really comes down to whether you can improve your finances with the help of Level Up. There's a compounding impact of making better financial decisions that will easily pay for itself.
Now, the really great thing about Level Up is that Lucas has created this unique pricing model. And so he can help you no matter where you are in your financial journey. That means if you are a junior dev just starting out, he has a pricing model for you. If you are a senior dev with 20 plus years experience preparing for retirement, he has a plan for you.
I like how you suggested I'm preparing for retirement right now.
Well, I mean, it's not like super close, but at this point in your career, you start thinking, hey, I need to get my stuff ready for that. Yeah.
And the good thing here is that Lucas is a fiduciary for his clients, which means that he's not here to sell you a product, but to actually help guide you to a better financial situation, which means that you're not going to spend money on something that doesn't necessarily help you.
So guys, you can catch his podcast, which is really cool. He now has a podcast, Techie Personal Finance Boot Camp, where he covers financial topics that you probably face and interviews other IT professionals who share how they navigated their careers. And you can also learn a lot more and find some fun free resources at levelupfinancialplanning.com.
Back in the day, applications often went years between deployments. When deployments happened, it was an ugly, slow, and painful process that took a tremendous amount of time and effort. Application management and diagnostic tools were limited, and these limits were often imposed by the software itself because most management functions were built directly into apps. It was even more annoying if you needed to spin up multiple copies of an application, move it to a different server, or change configuration information because this information was scattered all over the place in a variety of formats. The application was probably dependent on locally installed tools and libraries, and the application wasn't stateless. It was a nightmare. And frankly, it still is for some of my old employers who haven't, gotten with the 90s yet.
So, with the advent of cloud computing, we stopped treating servers like pets and started treating them like cattle. While this made it easier to quickly spin up infrastructure as we needed it, it also meant that certain old patterns of application development had to go away. In particular, we had to rework our applications so that their configuration information was stored in a predictable location, that application state was stored in a even saner location, and so that processing could be interrupted at any time because you never know when an admin is going to push a new configuration that will wipe out your runtime environment completely. It was a bit of an adjustment, and a lot of companies are still struggling with this to one degree or another.
And as things have gotten more complex, we've all had the urge to simplify our work. Not only does doing so make it easier to comprehend, it hopefully makes it easier to tell when we're doing something wrong. However, best practices always take a while to spread through the community, and they're often not platform agnostic, at least at the start. Thankfully, we now have some better general application guidelines that make it a lot cleaner and easier to develop cloud-native, modern applications that play nicely with modern DevOps tools, especially tools built around orchestration, deployment, logging, and storage.
So, guys, in this episode, we'll be discussing 12-factor applications, the 12 factors of 12-factor apps, which covers a variety of issues that make modern cloud-based development complex. If you follow these practices, it will be easier to build, maintain, manage, troubleshoot, and deploy your application in a modern environment. In the aftercast, we'll talk about how to handle legacy apps in a 12-factor way and what things to avoid if you're trying to build a 12-factor application.
All right, so we'll start off talking about the code base. 12-factor apps are always tracked in version control in a one-to-one correlation between the code base and the app. So in other words, you don't put multiple apps in the same repo. You use shared libraries instead of multiple apps because otherwise it's easy to get a partial deploy and get those kind of problems.
Now that makes sense. While there is only one app per code base, there may be multiple deployments of that same application.
Right. So you may have 2 copies of it behind a load balancer. You may have 100 copies of it, living in different client environments, possibly configured differently. But, it's the same app.
Yeah. Code bases are the same across all deployments in this case, but different versions may be active in each deployment.
So you'll run into this sometimes when you're consuming things off of message queues or you have API endpoints that are versioned.
Mm-hmm.
You may keep the old version alive for the old clients for a while you roll out the new version.
Yeah, I've done that before.
Yeah, and then eventually you choke the old one out. But, that may be hours after it's rolled out. It may be years, depending on the clients.
Yeah, it's tricky sometimes when you're like, all right, we have to move here. We need to go this direction. And you've got, these people who've been using the same thing for 10 years. You're like, all right, well, we're going to make you move. You don't get a choice in this matter.
Right. And especially as, security constraints and regulatory constraints kind of come in, you'll find that happens a lot. This makes it easier for anyone on the team to make changes and to redeploy the application when it's in source control like this and you have this kind of understanding without worrying that somebody deployed directly from their machine. Now, I have a horror story about this. I worked at a company where we had a developer who lost about, I think, 8 or 9 months worth of code on his machine that he had never checked in, but he had deployed to multiple clients directly from his personal machine. So now there were binaries running at the client site that we didn't have the source code to.
Okay. That's a certain kind of.
Yeah, that was real special. And you don't want this kind of thing happening, which is the reason you structure things this way, is because if you make it easy to deploy without deploying from your own machine, people will do the easier thing. Like, he got into this position because our deployments were awful.
Mm-hmm. That makes sense.
He didn't have good source control discipline.
Well, yeah.
This apparently was the second or third time something like that had happened.
I wouldn't have fired him. I would have made him like recode all of it within a certain time frame without overtime, but that's probably not really realistic.
Well, I mean, the thing about it is, if you're at a point where this happens at all, and especially if it happens more than once, the person that did it, like, there's a certain amount of blame there, but it's not all there, right?
Yeah,
like, you've got something else. Really, it's like when somebody asks, is this wetsuit fireproof? Like, if you're having to ask that question, it's more about what kind of life you're trying to live that doesn't really make a whole lot of sense. And you're in a situation that's like that. Like, there's assumptions.
That just sounds like something, from that Bruce Wayne would ask in the Dark Knight trilogy.
Yeah, but he would have a gravelly voice. Is this scuba outfit, is it fireproof? Got to kind of growl, No,
he only did that when he was Batman. This was when he was like Bruce Wayne.
Oh yeah,
that he would ask that question. So yeah. You need to like rewatch those, dude. It's been a while.
Yeah, it's been a while.
All right. So next are dependencies. You want to explicitly declare and isolate dependencies. Don't implicitly rely on things being installed on the system.
Yeah, and this one's kind of hard because, I mean, we're .NET developers, right? And we live on Windows mostly. Or at least our platform mostly is Windows.
I've written some cross-plat stuff.
And I have too, but there's an assumption. And a lot of .NET developers have been very comfortable assuming, okay, the framework is going to be installed and up to date.
Mm-hmm.
And on, this particular version is going to be available when I deploy this. So I'm not going to make sure that it's deployed and that it's the correct version. And this has burned quite a few people because some things do change and stuff breaks, or things work, differently in some manner.
I like it when you can say this is the version I'm expecting to be there, and it reads that from the config, goes out and makes sure that version is there.
And you want to be explicit about it, because the other thing you want is for people like your sysadmin to be able to tell what should be on there. Like when they're building up a Docker Compose or something like that, pull all the stuff in to make sure it is there. Now, the declaration of dependencies will be accomplished typically by means of some kind of manifest, and we'll use a dependency isolation tool to make sure that implicit dependencies don't leak in from the surrounding system. So in other words, okay, your app assumes .NET Framework's available. You run this thing in a container. The container doesn't have access to anything outside of itself. And so you've got to explicitly include it or it won't launch. That way you don't get burned at 3:00 in the morning when some admin's rolling it over to a new system and suddenly the framework's not there and he's got to call you.
Now, this also includes system tools like curl and other command line tools.
Or NPM.
Yeah, I was going to say that. If these are used, they need to be explicitly listed. Yeah, that's a big thing. Like working in Angular, and then this side project I'm doing is actually, it has a Node backend.
Yeah,
because it's kind of a fun little thing, but that we're building for this Scrum Master. But yeah, it's kind of neat, and so yeah, I've gotten burned a few times recently with that.
Yeah, especially stuff that you expect to be available in the command line. I mean, it'll get you real quick, or it'll get you in some really strange way. Like we've been having issues where some people are using like some old version of NPM,
mm-hmm.
and it's just some of the developers, and they'll check stuff in and it breaks for other devs. And then we, fix it on ours. We check in and it breaks for them. And so you really have to be very, very cautious and explicit on those kind of things. It also makes it a lot easier when you do this to set up a new environment for new developers. So, you spin up a developer machine. You go, okay, what has to be on here? All right, they're developing this app. Here's all the crap that this thing needs.
Yeah.
To be available for it. It also makes it easy when you run into vulnerabilities.
Yeah.
So I'm trying to think of a good recent example. The upgrade, any kind of like TLS type upgrade, some of those, came out and they're like, hey, this is real bad. We got to fix this soon. We found some vulnerability. If all your dependencies are explicitly listed, it makes it a lot easier to audit it versus asking the developers, okay, do you think it uses this under the hood? Because 3/4 of developers don't know.
Yeah. So a good way to think about this is, remember the last time you had to set up a new box, like from scratch, where, they gave you a new one from work and they didn't do any pre-work on it. They just were like, hey, we set you up an account. You're an admin. Go get the things you need. Yeah. Think about it like that.
Yeah.
You want to be like very like, here's the things I need for this to run, because you don't want to be like halfway through building something and realize, oh, now I have to stop what I'm doing and go install this and reboot my machine. And oh yeah, it's a absolute pain.
Well, and especially in the deployment considerations, because you're potentially spinning up new environments all the time. You're scaling up and scaling down potentially in response to load.
Yeah.
And so if all that stuff isn't there, the dude that has to write those scripts is going to not be happy with you. And he's going to basically go find all that, try to maintain a list himself versus the developers doing it. And so, periodically you'll push something out and it'll break everything because he doesn't know. So that has to be on us because we're the ones making the changes. Speaking of making changes, we need to talk a little bit about how configuration is managed in a 12-factor app.
Configuration is strictly separated from code and is not checked into revision control systems. Take note that this doesn't include configuration that doesn't vary between deploys, like routing information in a web app.
Yeah. I always have to kind of break that out because there's a lot of systems that sort of blur those lines. Like, and a perfect example of that was the old school web config in ASP.NET. Back in the day, it's like, okay, it's got your database configuration. That stuff shouldn't be checked into source control. But what assemblies you're loading, what dependencies you're loading was also in there. The way you're logging things was in there. You had, stuff that was almost like environment variable type stuff loaded in there. It was a mess. And all that stuff being together kind of made it pretty hard to manage. And so you don't really want all that configuration necessarily in there. Some of it should be go along with the code, but some of it really is completely separate. And it's basically comes down to whether or not the admin should be able to override that thing on a reasonable recurring basis. Like, yes, they changed the config, the connection string to the database. I can see that happening. I don't expect my AWS admin dude to change what version of some logging assembly is getting loaded by my app and to be aware of the innards of that. So he shouldn't be doing that. And so you understand that there's more than one kind of config.
Yeah. So 12-factor apps store configuration in environment variables to keep them out of the repository, make them easier to change, and keep them more operating system agnostic.
Yeah. And this is why you don't use things like the Windows registry for that kind of stuff, right? Like, sure, it works great. You can do all these policies and stuff. But the problem is if your app needs to run on Linux, now you've got to completely rework the way that you get your config information.
Yeah.
It could be kind of the same thing with files, but it's not as bad unless the file's in some kind of proprietary format, which is also pretty easy to get into.
Yeah.
in a 12-factor app, environment variables are never grouped, but they're instead, independently managed for each deploy. Note that most of the use cases where you're thinking, hey, these variables change together, like maybe like the pieces of a database connection string. If you're building it up dynamically, you got your host, you got your password, you got all this stuff. You might be tempted to say, okay, these variables should be grouped. What you probably are going to want to do for that is actually an example of what they call a backing service instead of a environment variable. So it's a little bit more complex and it's different than just individual toggles. Basically, you want to make it so that these things can vary independently without stepping on each other, if that makes sense.
Yeah. Now, this practice also makes it easier on SREs and DevOps to reason about how your application is going to behave while it's running.
Yeah.
I mean, I guess it shouldn't behave when it's not running because that would be really freaky.
That's a bad sign. Yeah. That's so the grouping kind of comes into this, right? So if you have an environment variable that's, that when it's not set to true, some other group of environment variables or several other environment variables no longer apply. That would be that's kind of a code smell from this sort of perspective. So if you say, hey, by default, this app reads and writes to a local SQLite database, and even if all the other SQL Server environment variables are set, if the one that says use SQL Server isn't set, then it writes to SQLite. That's now not predictable by the SRE unless they know about that.
No.
And so that's why you kind of avoid the grouping and the intertangling of these things. It's because the person that wrote the app is not the one trying to make it run.
That makes sense. So next are backing services. And a backing service is any service the application consumes over the network. While not part of the application itself, they are required for it to run. So, for example, I do Angular development right now. So the .NET API for my Angular app would be a backing service. The database for the API would be a backing service.
Yeah. And the idea with these is to configure them in such a way that they can easily be swapped out without changing code. So you can say, hey, point at this other database. So like if you have a failover copy, that's a read, read replica or something where you can say, hey, just, if this one goes down, change the config and now you're pointing over here, right? Like that's now scriptable to fix. But the thing about it is the app has to be written in such a way that it checks that value when it's about to go out to the database. It can't be caching that.
Same with like versioning for APIs.
Right.
Because if your API comes out with a new version, then just a little heads up, don't play with scissors while you're talking. You will snip your finger.
Okay. You never know.
I need fidget stuff and that is quiet, and those scissors were quiet. Yeah, that was a bad idea. Anyway, so yeah, what was I saying? Something about API versioning. Yeah, like you can do that with a version of the API. So if a new version comes out, you change it in the config.
Yeah, if it's compatible would be the only trick there, but maybe a different instance of it running somewhere else would be a good example of that. Now, these resources can be attached and detached from deployments at will. And, the whole caching thing really, really comes into it. So you have to be careful about the way that you're pulling that config information, because a lot of different environments really do like to cache that stuff. For instance, ASP.NET used to do this out of the web config. It would cache whatever was in there. And so if you were changing something like a connection string, you had to basically restart the app.
Yeah, I built this .NET Core background service. And if they wanted to add something, like I was basically polling these NAS folders, and if there's something in them, processing it. If they wanted to add a new folder, they had to restart the whole app. And I was like, all right. When we found that out, I'm like, we need to reevaluate how we're doing this.
Yeah.
Because it should just be a simple add it to the config. The next time it loops through, it pulls that config. And what it was doing is it was grabbing it that first time and just keeping that.
Yeah. I mean, the real big issue here is that your site reliability engineers, which is what an SRE is either site or service. I forget which one, but they're the people that keep the stuff running.
Yeah.
They like to move stuff around for various reasons. Either for failover, or they're moving to new hardware potentially, or they're up, they're scaling up for some reason or scaling down for some reason. Like they're dealing with all that kind of stuff, and so you don't want them to have to shut your app off to be able to switch out the database server. Potentially, like this is kind of what this allows. A database server is probably not the best example of that because of the statefulness, but think about a message queuing server, right? Where your app is broadcasting and isn't getting anything back from it. That might be a good example. You switch that over, it now broadcasts to the new one. The old one is still, sending those messages out, and they'll get processed and then shut down later. So this makes it a little bit easier to move stuff around without breaking things.
Yeah.
And without involving you.
So next is BRR, build, release, run. If we had just a B word for run, it would have been BRB. That'd been cool. In my pull requests, we have to put like how to test the code, and I've just started putting number 1 PBS, pull the code, build it, serve it.
Yeah.
And I've noticed the other developers are starting to do that because it's like, all right, this is pretty obvious.
Look at it, see if it's on fire. Okay. If it's on fire, it failed.
Yeah.
If it isn't on fire, now you can do the regular testing.
Yeah. And I get like you put that stuff in the first few because it's like, all right, here's how to like build it and stuff. And so I actually wrote a couple of scripts that make it even easier for us. So, but yeah, it's fun. Anyway, these phases of producing usable code are strictly separated. The build phase makes the code executable. The release combines this output with the config, and the run stage actually runs the code.
Right. So you don't want to do stuff where you're like dumping source out on a system and building on the fly.
Mm-hmm.
and then running that, right? Like the reason these pieces are separate is because they have different load requirements. You may be deploying to multiple environments. So you build it once and then you deploy it with different configs in different environments. And then obviously it's running in different environments at that point. You may have load balancing, failover type considerations. And so breaking these pieces up makes sense because you're not necessarily going to want to replicate all that work every time. The other thing here is that every release has its own release ID, and releases cannot be changed once they're created.
Yeah, so that's a funny thing. We had something weird happen. Actually, I think it was a build. Yeah, we had it was a build that was the issue, but we fixed it. Like we fixed the script, and then we did rebuild or and it just ran the old script because it was from the release.
Yeah.
And it was like the whole thing was like, oh yeah.
Well, because you want to be able to perfectly replicate that config.
And it makes perfect sense.
It's just hard to remember.
Yeah, well, it was one of those things like we did it and we're like, well, that didn't work. Let's try something else. And we tried 2 or 3 things before we realized, hey, this isn't doing we added a whole new step to the process and it did not ever hit that step. And we're like, something's not working here. And that's when we realized, we have to do a whole new, because it's a CI pipeline. So I had to do a whole new deploy for it, not just rebuild or re-release.
Right. Yeah. And this gets into some other things as well, because like your builds and your releases are developer initiated, because you don't do a build unless you change something.
Yeah.
right? Like, people go, oh, well, what if it was, volatile from day to day and we're building differently based on it being after a certain date? Like, that's kind of weird.
Yeah, that is weird.
That should be a configuration thing, not a build thing.
Yeah, but I would not be surprised if some people working with some older
Yeah.
things were
Well,
doing
that's why.
that, because I've seen some similar things, not that exact, but like some stuff. I'm like, you could make this easier on everybody with a week of work,
Yeah, like
and
not putting the date in, you know.
yeah,
You want to make that configurable. Part of the reason you want to do that is so you can test it before that launch date.
yeah,
Because if you're making it, if you're making a build that's based on your date, then you have no way to really test it accurately until that date hits. And oh, by the way, if you're going to that much effort, it's probably important.
mm-hmm.
So yeah, you'll initiate these, by the developer doing it. Releases may be kind of semi-automated. You're pushing out, you're building it up and configuring it for a new environment. But again, your environment variables are coming in from a person, probably. Maybe some other process, but more than likely a human being is in there somewhere. Whereas the runs of the software can be machine scheduled, right? Like the machine goes, hey, put this out here, run this Docker container for 5 hours, and then turn it off.
Yeah.
Because it's doing some kind of bulk processing and we need to scale out.
Now, breaking these steps apart and making them repeatable makes it easier to iterate on their implementations, which results in faster deployment over time. So,
I had to fix our serverless stuff yesterday because one of the some of the branch trigger stuff was missing that needed to be there. It was only triggering from the master branch, and like our other projects all had these regexes for how things are named across the teams that would make it fire and do a validation build. Wasn't doing it for our serverless. But the thing is, the only thing I had to touch was the build. Right? I didn't have to go in and say, hey, re-release this to all the environments because, hey, there's people working on those. I don't want to be poking those right now.
no, of
I would
course
not have been able to do that yesterday. I was barely
That
able to
would've
find the
been pain.
YAML files it was, but it took me a minute.
Yeah.
There's a reason you break these things apart is so that you don't have to worry about breaking something that you're not actually trying to touch.
Yeah. Yeah, that makes sense.
And then it did deploy. It deployed to all the environments anyway because the artifact filters weren't set right. But that was a release issue. That wasn't the issue I was working on. That was somebody else's fault.
Oh, wow. All right then. That happens too, I guess.
Well, it's fixed now because I fixed that too. Once I saw all the release messages pop up, I was like, "Hey, I didn't do that, did I?" Oop. But theoretically, they should have been blocking that and only been taking the artifact filter for the master, not for the feature branch I was working on. So there were two issues there. But had it been configured properly, it would not have been a problem. As it was, it still wasn't a problem because I just changed the branch triggers, so it didn't actually change real code.
Oh yeah, that makes sense. So the next thing we need to talk about is processes. Applications are run as a set of one or more processes. 12-factor application processes are stateless and share nothing. Shared state is kept in a persistent store.
Right. Above all, nothing stored in memory or on disk is assumed to be available for future work. Right. So you don't want to be keeping stuff in the web server's memory and going, okay, I have this. Next time a call comes in, I'm going to, if it's not there, then obviously I need to recreate it because, hey, you may be in a container that got shut down and now you're on a different server.
Now, this includes things like sticky sessions and cached assets that are output by some asset packagers. Now, of course, the former should be stored in persistent data store with expirations, while the latter should be composed during the build process.
Right. So you'll see situations where people are like, well, my app needs some image scaled to this size on this page. Great. Do that during the build process. Or you can do it at runtime and you stuff it in a file system that is not controlled by your app. It's a persistent store, across environments and across usages. You don't do it in the file system in the container or whatever that you happen to be using, because that can go away, right? It results in wasted work essentially, and can be a bunch of other errors and stuff too. Now, if you build processes this way, it makes it easier to move them between machines, scale them up, scale them out, or kill them off if they start having issues, right? Like if you have a process that is dumping stuff in a shared cache and it's malformed for some reason, you want to be able to kill that process without all the other processes in the system freaking out because now this thing isn't there and it was dependent on something that thing was doing.
Yeah.
Basically make it interchangeable parts.
So next is port binding. 12-factor applications don't require an outside web server. Instead, they're completely self-contained and export things like HTTP by binding to a port and listening to requests.
Now, if a web server is required, to host this thing, it has to be explicitly declared in a dependency declaration. So you don't go, "Hey, I'm hosting this under IIS or Apache," and my piece loads up and assumes that those things are on the system, right? Like it's explicit, it's there. You might do some kind of reverse proxying type thing, but you don't sit there and go, "Okay, well, I'm just going to assume it's present." Basically, The idea here is to run that web server in user space, so you're not running it as a regular, like as an admin. This dependency does not get injected at runtime. It happens as part of the build and release cycle. So all the code that needs to be there to run that ships with the app.
Now, this approach also means that an app can be a backing service for another app.
So you might, for instance, take your web API and you set it up as a backing service for your front end app, but your web API is listening to requests on a certain port, probably 443, right? But it may be mapping some other high range port to 443 inside, right? So the app doesn't really know about the external port. It knows its own port. And the idea here is that it makes it easy to swap instances of that thing out, even if it's just something that you built internally for use by your other apps.
That makes sense.
It also has a nice side effect in that the configuration for the server that you're using ships with the app rather than being something separate that varies independently from the application. Because, when moving parts vary independently, moving parts break.
Yeah. Yeah.
It's the same thing as in mechanics.
That makes perfect sense.
So next, let's talk about concurrency. In a 12-factor app, processes are first-class citizens, and each type of work will be assigned a different process type. Now, because processes are stateless and share nothing, it's easier to scale them horizontally, which is why you break it up into different types, right? Because, your login workflow, for instance, may be in one process type, and you don't want to necessarily scale that up massively, but your data processing process, it may need to scale independently. So this kind of lets you spin off more of them.
12-factor apps rely on their host operating system's process manager rather than attempting to manage these things themselves or spin up a daemon or Windows service to do it.
Yeah. And if you've ever had to do that, you'll understand why. There's a lot of very, very irritating things that happen when you're trying to run a background process like that and manage all its threads, manage, shutdown, manage power. And most of the time, really what you need is to go, "Hey, go do this thing and leave me alone." You don't want to go, "Oh, well, when you get a power off signal, do this. And when you get this thing, do this other thing." It's like, no, just, fire and forget.
Exactly. Of course, boutique process management systems tend to be difficult to code, and a lot of times they're not necessary. This approach allows development teams to focus on the value they are trying to provide rather than some esoteric process management constructs.
Because if that's not the thing you're trying to sell, it's really not worth creating, even though it maybe makes the developers feel good.
No.
So, the next principle is disposability. 12-factor app processes are disposable, which means they can be spun up or shut down on very short notice. Notice I didn't say instantly. This helps with scaling and speeds up deployment because now you can say, hey, this one's done, kill it off. Here's one that's ready, spin it up, and there's not a whole lot of lag time.
When a process is shut down, it's sent a SIG-term signal from the process manager and is expected to service any current requests and then shut itself down.
So it stops getting more requests in, it handles what it's got to do, and then it quits. So it's not instant, but it's fast enough that it might as well be.
Yeah, it's like
under most circumstances.
Because you wouldn't want it stopping immediately when you send the signal, because then whatever requests are in the middle of being processed would just disappear into the ether.
Yeah. And this is something you run into with Windows services because there is a timeout. And if you don't shut down quick enough, they just kill your process and you croaked right in the middle of something.
Yeah.
It's very, very difficult to deal with and do it well.
This also means that any work being done needs to be fairly granular if possible and restartable if it's not. And that usually requires some type of queuing infrastructure.
Yeah, this approach allows for rapid shutdown and spin up of new deployments, which makes it easier for DevOps people to manage infrastructure without noticeable downtime.
So next is development production parity. 12-factor apps are constructed with continuous deployment in mind, and this necessitates that development and production are as similar as possible. I worked at a place where all the development was like the dev servers were all internal, but like dev and test were internal. We thankfully had a UAT environment that was more like production, and it had like an externals because we had customers using it. And we found out that some stuff that worked when talking to the same server did not work when talking across the firewall.
Yeah.
And so they didn't give us an external dev server, but they did give us a pseudo external test server out of that big fiasco. And so I say it was a big fiasco. It was just it was a medium annoyance, really, is what it was. But sorry, I picked up the scissors again and was fiddling with them. I don't want to cut myself. No, sorry, y'all. It was one of those things. And so they gave us a separate, like, 2 test environments so that we could, and like a firewall between them so it could be as similar to production as possible before we got to UAT.
Yeah. Well, this actually pushes that down further. So the developer,
I know, that's what I'm saying. Like,
yeah.
And like, we couldn't get them to go all the way down to dev with it, but you know,
it was Oracle, right?
Huh?
It was like Oracle licensing.
Yeah.
Yeah. I mean, the thing is this has implications for any kind of backing service that you have. So database, message queuing, those kind of things, which makes it a bad idea to use a lightweight or different version of a backing service in development and production, because the differences will eventually cause problems. Like, this whole thing is built for continuous deployment. And so the developers, they push the thing out there, and if it looks like it passed, it goes out there. And so some difference is going to bite you in production if you have one.
All deployments of the same version of the app should use the same versions of the backing service to avoid this kind of problem. Not just the same versions, but like you were saying, not some like lightweight version. We're not going to use SQLite on the dev server and then SQL Server on the production.
Yeah. And that SQL developer to enterprise will make a difference too.
Yeah, that's true.
I've seen that one. Of course, that gets expensive to try to deal with. Now, this makes development easier because you don't have to think about the differences between local and production when you're writing code or trying to troubleshoot a production issue. So when you're coming back from production to your environment, you can still reason about it effectively.
Yeah.
And speaking about reasoning about things, logging is another thing that's very important here. 12-factor apps do not concern themselves with routing or storage of their output stream, nor with the management of log files. Instead, they use standard out unbuffered, period.
During runtime in production, this means that dealing with the output is a configuration detail rather than an application detail.
And this allows for better tooling around log management and also maintains statelessness and disposability, because now you're not writing to some log file somewhere and having to configure that. It's just like the app just barfs its stuff out and something downstream handles it, because that's not a concern of the app.
There are lots of very robust and powerful tools for digging through logs. Doing things this way allows your operations team to use those tools rather than whatever you thought was good enough when designing the system on your local environment. I know what we used for logging in the application, but for like service logging and like server logging, I'm not sure what they were using.
Yeah, well, think about, it's not a server logging, it's a server. It's an arbitrary server spun up for an arbitrary length of time that may go away at any moment.
Mm-hmm.
And there may be X number of them today and Y tomorrow. And so you really can't control the logs unless you just go, hey, I'm just going to kick it out to standard out and leave me alone. Y'all figure it out.
Yeah. So, guys, the last thing we're going to talk about is admin processes. Occasionally, one-off processes crop up. I mean, these happen. These should be run against a particular release and in an identical environment to the typical app environment.
And their code should also ship with the application code. The idea here is that these scripts, should be able to be invoked in the development environment from the shell or possibly from within the app itself. And in the production environment, they should be able to be invoked using SSH or other remote command execution mechanisms. So you don't really want this, to be some kind of one-off script that takes a lot of work to run, and it needs to be able to run in dev.
And you might run into still around some older people, system admins, who think they have to have their little, like, I have run into this where, like, doing some consulting where the people had their little fiefdoms and they're like, I've got my scripts and, no one else can have them because, I could lose my job.
And I'm not going to check it into source control because it's too much trouble. And then when the devs are trying to figure out what the heck you did, they can't look at it. I mean, that's the big thing there. It's a visibility thing. And it's I need to check what has happened to the script over time because somebody may have altered it. And hey, they just ran it this last week. And the guy that wrote it 2 years ago is like, oh, here's what it does. But somebody else touched it since then. And so it's about keeping a traceable trail of what causes changes with the things that are being changed.
This approach means that the content of any of these processes, has to be available for future stuff. You don't want to have those conversations like, well, Bob ran a script on prod. We don't know what he did.
Yeah. Or he ran a script on the client's prod. We don't know what he did. And all of a sudden they've got a breach.
Mm-hmm.
That's not a good place to be. So guys, 12-factor applications are a set of best practices that make it much easier and less risky to deploy and manage applications on modern cloud infrastructure. In addition to this lowered risk, they also make it easier to deploy applications continuously by limiting the variance between development and deployed versions of the same application. Finally, they also offer industry-standard ways of dealing with cross-cutting concerns like logging, configuration, process management, etc., with good tooling rather than the crap you cobbled together in-house under a deadline pressure. And that pretty much wraps us up. Beach, what do you have this week for us for Tricks of the Trade?
So this whole episode was about ways to simplify your process and make it easier on you. And I just want to say that simplification goes beyond just your workload and the things that you're doing there. Simplifying your life can lead to a higher quality living and even happier lifestyle. Now, I do want to say this doesn't mean you have to move out of your McMansion into a tiny home, nor does it mean going through everything you own and throwing it out if it, quote, doesn't bring you joy.
Yeah, that's an awful way to get rid of some relatives.
You can start simply simplifying your life by just choosing quality over quantity. So to pull a Will line here, back in the old days, back in my day, because he writes that a lot in his intros. No joke. I rewrite them sometimes just because he says it so much. But back in the old days, it could be described as having a small collection of your favorite DVDs instead of having a massive collection of movies you never watch. A different example, as a musician, I like guitars. I have several different ones. Will can see like a few of them sitting here behind me. I think I have 3 in this room, and they're all different. Like, one is a bass, one's an electric, and one's an acoustic. So, but there's a lot more that I want. And I don't go out and buy every cheap guitar I see. I would really like a couple of different styles, but I don't go out and buy every one I see. Instead, I choose to wait and save up for the nicer ones, the ones that hold their tone better, the better quality ones. And so what I'm getting at here is basically that simplifying your life is more about removing excess. So even, for example, cleaning out a closet or uncluttering a junk drawer will help. This week, I've been using that spare room of mine I told you guys I cleaned out last week. And it has been so nice to go in there and just, have a little bit of time to myself. I've been sort of reorganizing it, getting some stuff together. And it's nice having this extra space that I can just sort of step away from. I'm trying to train my dog not to go in there, so I can have like a little, away from him time that's not in the office working. But yeah, just uncluttering that room was so nice. And it took an afternoon to do.
I recently did that with my desk.
Yeah. I need to do that with my desk. I do it every now and then when I worked on my project last semester. I did it. So what I'm getting at here, guys, is that simplification doesn't have to be some massive change. In order to start living simply, just start one step at a time. You can also check out the Aftercast, where we're going to talk about handling legacy systems in 12-factor manner and things to avoid when creating a new 12-factor application. That's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly Aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.